Hello everyone, in this lesson we're going to be solving systems of equations using the substitution method. So what is that? So it is an algebraic method to find the point of intersection of two lines, two equations, and we are going to substitute or, in other words, plug in one equation into another. So we've plugged values into equations, but we've never really plugged a whole equation into another equation. So here are some steps for how we will use the substitution method. We will solve one equation for x or y. We will then substitute this expression into the other equation and solve for the variable that we have left. We will then substitute our answer into, I prefer not doing the revised method. I prefer putting it into the original equation. That way, if we made any mistakes along the way, we'd be sure to get we would be sure to catch that. And we want to solve for the remaining variable. If we plug it into both equations, that'll actually be a way for us to check and know in advance if we got the right answer. So you should always be able to tell if you got the right answer before you finish a system by substitution. So let's take a look at that. So in this first example, step one is actually already done for us. The equations are actually both solved for y, meaning y is all by itself. So I'm going to write the first equation, y equals 4x minus 1. So what I'm going to do is I'm going to substitute one equation into another. So I know that the other equation, y, is equal to 2x minus 5. Well, here's a y. So this y must be equal to 2x minus 5. So I'm going to replace that y with 2x minus 5. The other side I'm going to leave alone for a second. But now what we've done is we've created one equation, and the only variable in this equation is x. In the previous line we had two variables, y and x. That was too many variables in one equation for us to find the value of either of them. So now that we have one equation with one variable, now we can find out what the value of x is. So we'll go ahead and solve this. I'm going to go ahead and subtract 2x from both sides. And I'll get negative 5 is equal to 2x minus 1. I'll then add 1 to both sides. Negative 4 is equal to 2x. Let me bring that back up here. Negative 4 is equal to 2x. And I'll divide both sides by 2. That will give me negative 2 is equal to x. Now that's halfway done. We found the x value, but we also need to find the y value that represents the point where these equations intersect. So I'm going to go to the original equation, y equals 4x minus 1. I'm going to plug in my negative 2. So y equals 4 times negative 2 minus 1. So 4 times negative 2 is negative 8, minus 1 is negative 9. So that should be my point, negative 2, negative 9. How can we be sure? Let's take the x value we found and plug it into the other equation. So 2 times negative 2 minus 5. Okay, well, that is negative 4 minus 5, negative 9 again. Because we got the same number both times, that confirms that the x value we got was correct and the y value we have is correct. That's the only, negative 2 is the only number that when we plug it into both equations, we'll get the same y value out. So our answer to this question, the ordered pair for where they intersect is negative 2, comma, negative 9. Make sure you are writing your final answer as an ordered pair. Great. Well, let's take a look at number 2. Number 2, we have one equation that's already solved for one variable. Y is all by itself. The other equation looks a little different because it's written in standard form. But we're ready to basically do the substitution step because step 1 is done for us. So I'm going to take the equation that's not solved for it, where no variable is by itself. 2x plus 3y equals negative 20. I see a y in that equation and an x. If I can get just one variable in the whole equation, then I'll be able to solve. So I can replace this y, because I know what y is equal to, in my other equation. Y is equal to 6x. So 2x here plus the 3 stays. The 3 is not what we're substituting for. We're substituting for this y. So the y goes away. In y's place, we replace it with 6x. We still have equals negative 20 on the other side. Now, we have one equation with one variable we can go ahead and solve. So 2x plus 18x is equal to negative 20. So that's 20x is equal to negative 20, and we can divide by 20 on both sides to get that x is equal to negative 1. If we go ahead and plug this in, y equals, so in our first equation, 6 times negative 1, well, that's negative 6. If we want to confirm that, we can plug into our other equation. So 2 times negative 1 plus 3y should be equal to negative 20. All right, so this is really negative 2, so I need to add 2 to both sides. And 3y equals negative 18. If we divide both sides by 3, once again, we get that y is equal to negative 6. That confirms that our point is negative 1, negative 6. If we were to graph them, that would be the place on the graph where these lines intersect. So let's jump ahead and look at another example where we have a few new things come up. So if we go to number 5 on the next page, we'll notice that in this situation, in this system of equation, no variable is solved for already. We really have 4 options for a variable we could solve for: x in the first, y in the first, x in the second, or y in the second. It's like a literal equation where we have to solve one of them. We just got to get one variable by itself. If we do some thinking ahead, we can recognize that one of these variables is going to be easier to solve for than all of the others. In this situation, it's going to be the y right here, and that's because the coefficient of y is positive 1. We're not going to have to divide by anything. If we solve for this x in the first equation, we'd have to divide by 2 to get rid of that 2. If we solve for x in the second equation, divide by 5. Solve for y in the second equation, divide by 3. So this first y will be the easiest. So if I rewrite that equation over here, 2x plus y equals negative 2, the only thing I'll need to do is subtract 2x from both sides. And we get y is equal to negative 2x minus 2. Now we have an equation with a variable solved for. So y is solved for here. So we go to our other equation now. 5x plus 3y equals negative 8. Equation, 2 variables, we can't solve it right now, but we can get rid of this y by replacing it with what y is equal to. So the 5x stays, the 3 coefficient stays. Y is what's gone, and y we know is equal to negative 2x minus 2. So the whole expression here, negative 2x minus 2, and then equals negative 8 on the other side. Make sure you're putting it in parentheses there if it's got multiple terms. So 5x plus, oops, it's going to be a minus, because we have 3 times negative 2 is negative 6x. 3 times negative 2, negative 6. Okay, and then equals negative 8 on the other side. Okay, let's combine like terms. We've got 5x minus 6x is negative x, minus 6 equals negative 8. We'll add 6 to both sides. Negative x is equal to negative 2. I'll write that again up here. Negative x equals negative 2. And we can divide or multiply by a negative 1 either way, and we get x is equal to positive 2. So we need to plug into our original equations. So 2 times 2 plus y is equal to negative 2. So cutting a little step out here, that's really 4 up there, so I'm going to subtract 4 on both sides, and we'll get that y is equal to negative 6. Let's check the other equation. 5 times 2 plus 3y equals negative 8. Well, that's 10, so I'm going to subtract 10 on both sides, and 3y is equal to negative 18. If we divide by 3 on both sides, we get y is equal to negative 6. So our final answer, 2, negative 6. We confirmed it by plugging it into both equations. You don't have to plug it into both equations, but that does help confirm to us that we got the right answer. Okay, I want to look at some special cases. Let's look at example 7 here. So if I'm looking at the 4 options for what to solve for, this x is going to be the easiest to solve for, coefficient of positive 1. So to solve for that, let me rewrite it here. Let me subtract 5y from both sides. Great. So we haven't seen when we actually solve for x yet, so we can still do that though. So x is equal to negative 5y plus 4. Okay, let's take our other equation. Always make sure you're taking the other equation. If you plug this equation here, that I've asterisked, back into the first equation, that's the equation it came from. If you plug that in there, it will not work. You'll get kind of a funny situation. You'll get a true statement. So we'll make sure you're plugging it into the second one. Okay, so 3x plus 15y equals -1. Okay, so I found x this time. So this x we're going to get rid of. So 3 stays, -5y plus 4k. Close the 4k. Just plus 4. That's my little asterisk there. Plus 15y is equal to -1. Great. So the 3 will distribute in, so I get -15y plus 12 plus 15y equals -1. So we have a -15y and a positive 15y. So they cancel out. We're left with 12 is equal to -1. Don't be fooled. 12 is still not equal to -1. This is a false statement. And like we've seen in past chapters, when we get something that's false, this means there's no solution. Well, how's that possible? Well, if we're talking about where lines intersect and these lines have no solution, they do not intersect, these lines, this is not really required, but these lines are parallel. So no solution is our answer. It's because the lines were parallel. Okay, let's check out example number 9 as our final example here. All right, so if we're looking at the 4 variables here to solve for, here, this positive y is going to be the easiest one to solve for. So 2x plus y equals 18. We'll subtract 2x from both sides. And we'll get y is equal to -2x plus 18. So we go to our other equation, 6x plus 3y equals 54. Great. So we can get rid of y here because we know what y is equal to. So 6x plus 3, open parentheses, -2x plus 18 is equal to 54. So 6x, we're going to distribute, so minus 6x, and then plus 54 is equal to 54. 6x minus 6x cancels out, and we're left with 54 is equal to 54. Well, that's odd. It's true, but it's odd. So when we get a true statement, this means that there are infinitely many solutions. How is that possible? It's possible because these are actually the same line. If we were to actually solve both of these equations for y, the first equation would actually also be y equals -2x plus 18. They're the exact same line graphed on top of each other, so that means they intersect in infinitely many number of places. There's an infinitely many solutions to this system of equations. So with that being said, now you've seen a variety of different types of systems equations. Make sure that if you get a solution, you're writing as an ordered pair, but if you get a true statement, that's infinitely many solutions, and if you get a false statement, that means there's no solution to that system.